simply take left hand side and cosec cot, and here we see in terms of cos. So it makes sense to change everything in terms of sine and cos. So let us first write the given equation which said cosec theta minus cot theta and whole square of this. Cosec theta can be written as 1 over sine theta. Cosec is a reciprocal of sine. So cosec theta can be written 1 over sine theta minus cot theta is cos theta divided by sine theta. Hope you have learned this formula already. Cot theta can be written as cos by sine and square of this. Well, we can easily take LCM, so it comes sine theta in denominator. Inside the bracket we are solving. And then it is 1 minus cos theta and whole square of this. Now we can write it as 1 minus cos. We can split the numerator. I mean, we can write the square separately in the numerator and denominator. So means 1 minus cos theta whole square and divided by sine theta whole square, and sine theta whole square means sine square theta. We can write it sine square theta. Now we are going to use the identity like sine square theta plus cos square theta equal to 1. Using that, we can write 1 minus cos theta whole square as it is. And in place of sine square theta, we are going to write 1 minus cos square theta. Now look at the denominator, which is in the form of a square minus b square, because 1 can be written as 1 square. So this can be written as 1 minus cos theta whole square divided by 1 minus cos theta and multiplied 1 plus cos theta. Now 1 minus cos theta whole square and 1 minus cos theta, we can cross it out. One of the factor gets cancelled. Finally, we arrive to the right hand side, which is 1 minus cos theta divided by 1 plus cos theta. For question number second part of question number 5, we have this expression. Again, we will be taking left hand side. So the left hand side of this expression is cos of A divided by 1 plus sine A and plus 1 plus sine A divided by 1 plus sine A divided by cos A. So there are two fractions, so it makes sense to take LCM of this. We will take LCM, which is 1 plus sine A multiplied with cos A. Whenever you have different terms in the denominator, nothing is common in these two terms, so we simply multiply them to find LCM. Next, cos squared theta, which is cos into cos, cos square A plus, and this is 1 plus sine A whole square. Now, cos square A as it is, cos square A, and I think we can open this bracket that A plus B whole square would be A squared, A is 1, and B squared, B is sine A, so sine square A square plus B square plus 2AB, 2 into 1 into sine A. So that is 2 sine A divided by, in the denominator we have 1 plus sine A as it is, and it has to be multiplied with cos of A. Well, after this, we can write it next, because we can see these two terms, sine square a plus cos square a together, and that will be 1. Okay, so we can write 1 plus 1 plus 2 sine a divided by 1 plus sine a and cos a. Obviously 1 plus 1 would be 2, so we get 2 plus 2 sine a divided by 1 plus sine a into cos a. 1 plus sine a multiplied with cos a. We can easily see if we take 2 common in the numerator. So we get 2 common, 1 plus sine a divided by 1 plus sine a, and this is to be multiplied with cos a. Well, we can easily see sine a's can be cancelled, 1 plus sine a, 1 plus sine a. We got 2 by cos a. This is equal to 2 divided by cos of a, and 1 by cos a is sec a. So 2 into 1 by cos a, that means 2 sec a. So this is, we arrive to the right hand side. So we proved second part of question number 5, third part. It says, yes, I think there is some typo here. So this is something in terms of sec and cosec. This is the left hand side on this. So let's take the left hand side and simplify. Left hand side, tan theta, and the things that we have to prove is in terms of sec cosec, it looks like. So it would make sense to change everything into sine and cos. So left hand side, sine theta by what? Tan theta can be written as sine of theta divided by cos theta. And this divided by 1 minus cot can be written as cos of theta divided by sine of theta. And plus cos theta is cos theta by sine theta. And 1 minus tan theta means 1 minus sine theta divided by 1 minus sine theta divided by cos theta. We can take LCM in the denominator of both fractions. So this thing is equal to sine theta by cos theta. We keep the numerator as it is, and in the denominator we are going to take LCM. So the LCM is sine theta, and then sine theta minus cos theta. Sine theta minus cos theta. Look, this 1 is written as sine theta by sine theta. You can consider it like this also. Then this minus this, so you are getting it. Yes. Now, this is to be added with the other part here, cos theta by sine theta. Cos theta divided by sine theta. And we are dividing here also, we're taking LCM, cos theta. So we're writing everything as it is, just taking LCM in the denominator. So cos into 1 is cos theta minus sine theta. Yes. Now, since this is a fraction, there are two fractions in numerator and denominator. So whenever we divide two fractions, we multiply with the reciprocal of the function of the fraction by which it is divided. What we mean to say is this fraction over here is going to up in the numerator and getting upside down. Okay, how do we write it? That means sine theta by cos theta as it is. And this expression up there, sine theta goes in the numerator and in denominator sine theta minus cos theta. Okay, and plus same with this fraction also, cos theta by sine theta, and upside down, so cos theta and cos theta minus sine theta. The next step is we would like to take LCM of this denominator. Look, sine into sine is sine square theta in the numerator, and in denominator we have this fraction, this expression, and here in the denominator we have this expression. So we would like to find LCM of these two terms. One thing we notice that this is sine theta minus cos theta, and this part is cos theta minus sine theta. There is difference of negative sign, means if you take -1 common, this part, this factor and that factor will become same. So we want to take -1 common from here and make it sine theta minus cos theta. So if -1 is taken common, the inside bracket sign of these terms change. So that's what we are going to do, and we will write that minus sign here in front, and actually that can be written in at the center as well. So the next step would look like this. We would have this is equal to sine square theta divided by cos theta, first term sine theta minus cos theta, and for the second term we are going to take -1 common from the denominator. And you know that in a fraction, suppose a fraction is x over y, so it is the same whether denominator is negative or numerator is negative, or you write negative sign in the center. All these three expressions have the same meaning. So means after taking that negative sign common, we are going to replace this positive sign by negative, and your numerator is cos square theta, and in denominator sine theta, and here sign of these things will change because of this negative sign. So this becomes now sine theta minus cos theta. Now this is very interesting. Now it's easy to find, see, LCM, because one of the factor we find common, sine theta minus cos theta, sine theta minus cos theta. And the non-common factor will simply multiply. I think till here it is all clear. Now we are going to write, because after taking LCM, then we see this sine theta, this sine theta over here will get multiplied with this sine square theta. So this term becomes sine cube. And similarly, after taking LCM, this cos theta will get multiplied with this cos square theta to get you cos cube. You know why? Because the LCM is sine theta, cos theta, sine theta minus cos theta. So we're going to write it. We're going to write LCM first. Let's see the expression. Yeah, sine cube minus cos cube, and then yes, the numerator would be sine cube minus cos cube, sine cube theta minus cos cube theta, and in the denominator we will have sine theta cos theta and sine theta minus cos theta. Now this is almost done, because in the numerator you have a cube minus b cube, and the identity for a cube minus b cube is a minus b, that is sine theta minus cos theta, and then a square plus ab plus b square. That means a is sine theta, so square of a is sine square theta, plus ab means sine theta cos theta, and plus b square. Let's write it little carefully so that all these terms comes here. Okay, sine theta minus cos theta, and then put a bracket right here, then a square, which is sine square theta minus plus, that is, this is the formula, plus ab, no, sine theta cos theta, and plus b square, b is cos theta, so cos square theta, and bracket equals. Yes, and this divided by denominator is, your LCM is sine theta cos theta and sine theta minus cos theta, and we are done. This sine theta cos theta is gone. And look up here, this sine squared theta plus cos squared theta is 1. So we can write this is equal to 1 plus sine theta cos theta sine theta cos theta divided by sine theta cos theta. Look, this is something, I think this is equal to 1 plus sec theta, that we need to prove it is equal to 1 plus sec theta cosec theta. All right, and that's what we are getting here. Now we will split these two terms, this into two terms. So 1 over sine theta cos theta and plus sine theta cos theta divided by sine theta cos theta divided by sine theta cos theta. One thing, while you are watching it, you should write it. That is the best way of learning this, right? Take a pen and write. That is must. Whichever video you watch, pen should be in your hand and you should be writing all together. So it is 1 over sine theta cos theta means 1 over sine theta into 1 over cos theta. We can write it like this, 1 over sine theta into 1 over cos theta, and plus the sine theta cos theta get cancelled, we get 1. And 1 over sine theta is cosec theta, and 1 over cos theta is sec theta. Cosec theta, sec theta plus 1. That is your right hand side. Next identity is the fourth one, and this says 1 plus sec a by sec a is equal to sine square a by 1 minus cos a. So we, in this also we can take either side. Okay, let's take the left hand side, and then it's your choice, whichever way you like. You can take the right hand side also and then work on the identities or things and go to the left. Well, let's take left in this case. So 1 plus sec a, and by sec a on the right side we have in terms of sine and cos. So obviously we will change everything into sine cos. 1 plus sec a can be written as, let's write the left hand side first, 1 plus sec of a divided by sec a. That is 1 plus sec a can be written as 1 over cos a, and this gets divided by 1 over cos a, because sec a can be written as 1 over cos a. Obviously we would take LCM of numerator. LCM would be cos a, and then we will have cos a plus 1. That's how we take the LCM, cos a plus 1. And 1 by cos a as it is, 1 over cos of a. Now we are going to write this fraction. Let's make a partition here, and we are going to write it as cos a plus 1, or 1 plus cos a is the same thing. The numerator can be written as 1 plus cos a. All right, we can write 1 plus cos of a divided by cos of a multiplied cos a over 1, because this fraction gets upside down. Look, this cos a and cos a gets cancelled, and we are getting 1 plus cos a. That should be our right hand side. But hey, no, it's not yet done. The expression, it looks slightly different. Well, if we get this, we can find this thing as well. And how will you do that? Simply 1 plus cos a can be written as 1 plus cos a over 1, and we would multiply numerator and denominator of this expression by 1 minus cos a. So that means this thing can be written as 1 plus cos a divided by 1, and we can multiply and divide both side with 1 minus sine a, no? So that's what we are going to do. All right, so numerator, as we see, numerator is now a squared minus b squared, and a squared minus b squared is, now this should be written in bracket. So it's like a plus b, a minus b, which is a squared minus b squared. A is 1 and square of 1 is 1. 1 squared minus sine squared theta. Oh, hold on. It's like a squared minus b squared, b is cos. 1 minus cos square a divided by 1 minus, we multiplied by, why did we multiply by 1 minus sine a? Oh, hold on, there is an error, we should fix it. Because we want to make it 1 minus cos square a, so we should multiply by 1 minus cos a. Here also you see in the denominator you have 1 minus cos a, so it looks like you'll multiply this 1 by 1 minus cos a, no? Makes sense? Yes. Cos a. So 1 minus cos square a divided by 1 minus cos a, and 1 minus cos square a is an identity which is equal to sine square a divided by 1 minus cos a, and we are done. From the right hand side, left hand side, we have proved right hand side. Let's see another way of doing this question. Suppose we start with the right hand side. Okay, this might look little different, but it is the same thing. Sine squared by 1 minus cos a is the right hand side. So let's write it. Sine square a by 1 minus cos a, which would be equal to, sine square a can be written as 1 minus cos square a. 1 minus cos square a divided by 1 minus cos a. Now 1 minus cos square a means 1 plus cos a, 1 minus cos a. Can we write it? This is equal to 1 minus a square minus b square can be written as 1 plus cos a divided by 1 into 1 minus cos a divided by, yes, and now 1 minus cos a should be cancelled. So we are getting this is equal to 1 plus cos a, 1 plus cos a by nothing, that means by 1 we can write, because we want to express in terms of sec. So we will divide both numerator and denominator by cos a. Or if you think like why we are dividing both numerator and denominator, one way of doing it, like you simplify your right hand side to 1 plus cos a, and then you simplify your left hand side also. Left hand side, which would be is equal to 1 plus sec a means 1 by cos a, and then again sec a 1 by cos of a. This will be written as, taking LCM, cos of a plus 1 divided by cos a, and this whole divided by 1 by cos a. Well, when we write it, this fraction upside down, this would be cos a plus 1, which is 1, can be written as 1 plus cos a, divided by cos a into 1 by cos a upside down will become cos a over 1. Now we look at this and this gets cancelled. So we are getting the left hand side is also equal to 1 plus cos a. So what does this mean? That means both left hand side and right hand side are same. So this is another way of doing the same. Cos a minus sin a plus 1 divided by cos a plus sin a minus 1 is equal to cosec a plus cot a. Yes. So the right hand side is in terms of cosec and cot. We can start with the left hand side and change everything into cot cosec. Yes. Left hand side. Cos minus sine. This is cos of a minus sine of a plus 1 divided by cos A plus sin A minus 1. So I encourage you to write while you are watching. It's all about writing, yes? So you must write also to understand it better. Well, we will divide numerator and denominator by sine theta to get in the terms of cosec and cot, because cosec is 1 over sine and cot is cos over sine. So that's why we are dividing numerator and denominator by sine theta. So this term can be written as cos A. Sine theta means sine A in this context. Sine A minus sine A over sine A. Sine A over sine A. And plus 1 over sine A. 1 over sine A. This divided by cos A over sine A. Cos A over sine A plus sine A over sine A is 1 again. Sine A over sine A. And minus 1 over sine A. Now this is being changed into cot and cosec. Look, this is cot A. We can write this is equal to cot of A minus this value is sine A by sine A is 1. 1 by sine A is cosec A. Cosec of A divided by cos by sine is again cot A. Cot of A minus, so it's a plus 1 minus 1 by sine means cosec of A. Now, as we see in this right hand side, we have to get cosec and cot. So we would like to change this 1 that you can see here in terms of cosec and cot. And the identity that we are going to use here is cosec square theta is equal to 1 plus cot square theta, or cosec square theta minus cot square theta is equal to 1. So this is the identity that we are going to use here. Let's use it here, rewrite it. And now this thing can be written as this is equal to cot theta plus cosec theta as it is. Cot theta plus cosec theta. This is as it is. In place of 1, minus 1, no. So can we write minus? In place of 1, we are going to write up here this identity, which is cosec square. Hello, it's not theta, it's A. Yes, so it is A. Cot A plus cosec A, and cosec is minus cosec square A minus cot square A divided by, in the denominator, we are going to keep everything as it is. Cot A plus 1 minus cosec A. Now, this term over here can be factorized and can be written as cosec square A minus cot square A can be written as cosec A plus cot A, cosec A minus cot A. Okay, can we write this expression up there? Means we want to write everything up there so that we could take common, and this would look like, look at the denominator. Denominator is cot A plus 1 minus cosec A. Okay, that's right, everything up there. Cot A plus cosec A. The term was cot A plus cosec A minus cot square A. This was cosec square A minus Let's write it again. So it was inside bracket cosec square A minus cot square A, like this. And well, this divided by this thing we didn't change. So we got it by dividing sine theta, means this must have been cot A, and sine A by sine A is 1, and 1 by sine A was cosec minus cosec A. Right, because the denominator we got dividing this by sine, so the denominator we know. Now we are going to factorize this. In place of cosec square A minus cot square A, we are going to write cosec A minus cot A, and one more factor, which is cosec A plus cot A. Look, since addition is commutative, that means this term over here, cosec A plus cot A, and this term is same. So this is a common factor in the numerator. So we are going to take that common. So what we are going to take common? Cot A plus cosec of A. If this is taken common, from this part over here, 1 is left. And can we use capital bracket here? Yes, we should use capital bracket. Look, from this part, we have taken everything common, so 1 is left. You see there? So 1 is left from there, minus. From this part, we are going to take this, we're going to take cosec A plus cot A, this thing common. So we are left with this, means we are left with minus of cosec A minus cot A, like this. And in the denominator, we have all things as it is. Cot A plus 1 minus cosec of A, like this. Look, the inside bracket, this term is same as this, because if you open the bracket, you get exactly same thing as you have in the numerator. So what we mean to say is this thing will be equal to, look, I just want to show you that this numerator factor, when you open up the bracket, it becomes same as this, and this get cancelled, and you get cot A plus cosec A, which is same as right hand side. Okay, actually you should show this part in the next step, where you will write this is equal to, let us write here, this would be is equal to cot A plus cosec A, cot A plus cosec of A, and this is multiplied with 1 minus cosec A minus plus cot A. Open the bracket of the numerator and divided by denominator is cot A, this is positive cot A, positive 1 minus cosec A. So it can be written exactly same as 1 minus cosec A, because negative of cosec A here you see, and positive of 1 and positive of cot A. What I mean to say is when you write it like this, and then you can show that this factor over here, this factor is same, gets cancelled, and your right hand side is cot A plus cosec A. So which is equal to right hand side you can write. So right hand side and left hand side are equal, and this part is also proved. Next is a square root of this 1 plus sine A divided by 1 minus sine A equal to sec A plus tan A. Let's take, we can start from the left hand side. Let's take the left hand side, and we can see the square root in the left hand side. So that means it is 1 plus sine A divided by 1 minus sine A, something like this. So we are going to maintain this positive sign, 1 plus sine A, this positive sign, this positive sign. You look at this. So these two signs are maintained. That means we are going to multiply numerator and denominator inside this square root, and we are going to multiply them by 1 plus sine A. 1 plus sine A. I mean, when we start with the left hand side, we will write it like this, and then is equal to a square root 1 plus sine A as it is, divided by 1 minus sine A. This was our original question, and we are multiplying this by 1 minus sine A, 1 plus sine A, I'm sorry, 1 plus sine A, and we also divide this by 1 plus sine A. What do we get? Inside is square root. The square root sign is as it is, and inside is square root sign, we'll get 1 plus sine of A whole square. And this is to be divided by 1 minus sine A, 1 plus sine A, that is 1 square. A plus B, A minus B is A square minus B square. B is sine A and the square of it. You can write the identity, the one you are using, because A plus B, A minus B is equal to A square minus B square. Now this is equal to a square root remains as it is, and 1 plus sine A whole square, this divided by 1 minus sine square A, well-known identity, is equal to cos square A. Now we have the square in numerator as well as denominator. It can be written as under root of 1 plus sine A. Look, the numerator is also square, denominator is also square. That means this can be written like this, whole square of this. Now this square and square root gets cancelled, and we get 1 plus sine A, 1 plus sine A divided by cos A, which is same as, now we can split it, 1 by cos A plus sine A by cos A, which is same as, is equal to 1 by cos A plus sine A by cos A. And 1 by cos A is sec A, and sine A by cos A is tan A. That is sec A plus tan A. And we are done. This is equal to right hand side. The next one is, well, we have question number 7 part of question number 5. We have to prove sine theta minus 2 sine cube theta by 2 cos cube theta minus cos theta equal to tan theta. So let's take left hand side, and as we see, tan theta is sine theta by cos theta. Tan theta is sine theta by cos theta. So it would be useful if we can take sine theta common from the numerator and cos theta common from the denominator, and which is common, yes. So let us write it first. Sine theta minus 2 sine cube theta divided by 2 cos cube theta minus cos theta. We are going to take sine theta common from numerator. So sine theta common, 1 minus 2 sine square theta. From the denominator, we are going to take cos theta common, and then we have 2 cos square theta minus 1. Now, since we have to get tan theta, that means these two should get cancelled. For that, we can change either sine theta into cos theta or cos theta into sine theta. We have the identity sine square theta plus cos square theta is equal to 1. Okay, so we are going to use this identity here, and we take we keep the sine theta by cos theta as it is. So this is sine theta as it is, cos theta as it is in the denominator, And let us keep numerator as it is, 1 minus 2 sine square theta. And we are going to change that cos square theta from here. What we get cos square theta is equal to? No, cos square theta would be 1 minus sine square theta. So we are going to change cos into 1 minus sine square theta. So let's use this capital bracket and then 2 1 minus sine square theta, bracket closed, minus 1, and you close the capital bracket. This means we are getting all this thing is equal to sine theta by cos theta as it is. And if when you open up the bracket in the denominator, you will get 2 minus 2 sine square theta minus 1. Look, simply open the bracket here and see what you get. 2 minus 2 sine square theta minus 1. Now this 2 minus 1 is 1. So 1 minus 2 sine square theta. Do you see? This part is same as this part. Okay. So what we can say is these two terms can be cancelled. These two terms can be cancelled. So we're gonna write it as sine theta, the 1 minus 2 sine square theta, and here also we have cos theta, and after simplification this also comes out to be 1 minus 2 sine square theta. So finally sine square theta cancel. 1 minus 2 sine square theta and 1 minus 2 sine square theta is gone. We have sine theta by cos theta left. And sine theta by cos theta is same as tan of theta. So from the left hand side, we find a right hand side. In the eighth part, we have like a plus b whole square, a plus b whole square. And look, we have to get in terms of 7 plus something. So simply we can apply a plus b whole square identity. So we get sine a plus cosec a whole square. Let's start from the left hand side. Sine a plus cosec a whole square means a square, which is equal to sine square a, plus b square is cosec square a, plus 2 sine a cosec. 2 sine a cosec a. Cosec a. This is the expansion of the first a plus b whole square. And then next we have plus again a plus b whole square. So this is cos square a plus sec square a plus 2 sec a cos a plus 2 a b. Yes. So this is very simple. I think a plus b whole square. So a square plus b square plus 2ab. A square plus b square plus 2ab. Now there are the terms like we have the sine square a plus cos square a. That will give us 1. So we want to bring them together. So we get sine square a and cos square a in one bracket. Sine square a plus cos square a. This is sensible because we want to get this 7 here on the right side. So sine square a plus cos square a and plus, can we write cosec as 1 plus cot square a? Yes, we can. So cosec square a can be written as 1 plus cot square a. This is the identity. And same way sec square a can be written as plus sec square a is 1 plus tan square a. Sec square a, this sec square a is same as 1 plus tan square a. And then 2 sine a cos a means 2 sine a as it is. And in place of cosec a, we can write 1 by sine a because cosec is the reciprocal of sine. and plus finally we have this term, which is 2 sec A cos A. 2 sec A means 1 over cos A, 1 over cos of A, and multiplied cos A. Now this cos A should be cancelled. Sin A should be cancelled. And sin square A plus cos square A is 1 plus 1 plus 1, you see, 1, 1, 2, 2. How much? 1 plus 1. This is for sin square A plus cos square theta. This is second one, third one. So how many one you have? 3, 1. Okay. And then plus 2 for this, plus 2, plus we have these terms now. Cot square A, tan square A, plus tan square A, plus cot square A. So we got the right hand side. 1 plus 1 plus 2 means 7, plus tan square A, plus cot square A. So we got the right hand side. So it was simple, just apply A plus B whole square. And well, then the trigonometric identities that we applied, all three trigonometric identities we applied, the sine square theta plus cos square theta equal to 1, we applied 1 plus tan square theta is equal to sec square theta, and we also applied 1 plus cot square theta is equal to cosec square of theta. Also, the reciprocal of sec theta can be, which is cos theta, we applied this, and we also applied in place of cosec, we wrote cosec theta is equal to 1 over sine theta. So this was all the identities which were needed, and well, we also needed a plus b whole square. A plus b whole square is equal to a square plus b square plus 2ab. Yes, and next we have this question, sec cosec minus sine sec minus cos is equal to 1 over tan A plus cot A. Again, since sec, cosec, sine, cos, everything you see there, so it will make sense to change everything into sine cos. So let's start from the left hand side. Cosec theta is 1 over sine of A, cosec A, and minus sine A as it is. We're starting left hand side. We should first write this part, then this is the second step. Okay, multiplied by sec is 1 over cos. Sec is the reciprocal of cos, and minus cos of A. So this is going to be sine A as it is, and 1 minus sine square A. Yes, taking LCM, and this multiplied by cos A, and this is 1 minus cos square A. Now, what is 1 minus sine square A? Well, 1 minus sine square A is equal to cos square A. And what is 1 minus cos square A, which is equal to sine square A divided by sine A cos A. Sine A cos A. It looks like we can cross out cos square with cos, sine square with sine. So we getting this is equal to sine A cos A. In the numerator we see, actually this is cos A sine A. Does not make much difference, cos A sine A. But on the right hand side, we do not have sine A cos A. We have a term like this. So what we can do is, we can write this is equal to cos A sine A divided by 1. Can we? This thing is same as cos A sine A divided by 1. Cos A sine A divided by 1 means we want to say, because we would like to change everything in terms of tan and cot. So this is cos A sin A. And in place of 1, we are going to write identity, that is sin square A plus cos square A. 1 can be written as sin square A plus cos square A. Now look at this. This we have to show like this. So what we are going to do is we are going to divide both numerator and denominator by cos square A. So when you divide numerator by cos square A, what do you get? That is equal to, let's write here, cos A sin A, cos A sin A divided by cos square A. And in the denominator also, we write sin square A divided by cos square A plus cos square A divided by cos square A. So we simply divided both numerator and denominator by sin A cos A. Oh, not by sin A cos A, rather we should divide it by, yes, we want 1 in numerator, not by cos square A, divided by sin A cos A. Divide by sin A cos A, both the terms, right? So we are going to divide it by sin A cos A. And we are also going to divide the denominator of both the term by sin A cos A. Here also we are going to write sin A cos A and the sin A cos A. That means this should be sin A cos A cancel. So we get 1 in the numerator, and in the denominator, we are getting sin square A sin square A divided by sin A cos A. So the square and this is sine should get cancelled. The square and cos should get cancelled. We get sin A by cos A. That means tan A plus here we get cos A by sin A, tan A plus cot A. So this is the right hand side of the identity. So we started from left hand side and we reached to right hand side. Next, we have one more identity, I guess. And this is that we have to show these 3 expressions are same. Well, let's take the left hand side first. Our left hand side is 1 plus tan square A. 1 plus tan square A divided by 1 plus cot square A. Now 1 plus tan square A is sec square A. So this is sec square A and 1 plus cot square A would be cosec square A. So, well, we can change this into sin cos now. This is equal to 1 by sec. Sec is the reciprocal of cos, can be written as 1 by cos square A divided by cosec is the reciprocal of sine. So this is can be written as, and finally we can write this as 1 over cos square A into sine square A divided by 1, which is same as sine square A divided by cos square A. Well, so the left hand side, this term, it's same as tan square A because sine by cos is 10. So this thing is tan square A. So we have shown this, the first term is same as tan square A. Can we show the second term is also same as tan square A? Then we can say these all 3 terms are equal. To show the second is equal to tan square A, we will take now 1 minus 10a divided by 1 minus cot a, and we are going to square it. Look, 1 as it is. 10a can be written as sin a by cos a, and divided by 1 minus cot a is cos a by sin a. Yes or no? Now, square of this, we would like to square it. Taking LCM, this part will look like cos a in the denominator, and then this should be cos a minus sin a, cos a minus sin a whole square, and this divided by here in the sin a in the denominator, and then this should be sin a minus cos a, and the square of this. This whole thing can be written as in the numerator. Look, one thing, a minus b whole square is same as b minus a whole square. Do you know this? Yes, when you expand these both expression, you'll get same identity, a square minus 2ab plus b square. So whether you square a minus b or you square b minus a, you get the same expression. So can we say a minus b whole square is same as b minus a whole square? So the numerator thing, which is cos a minus sin a whole square divided by cos a whole square means cos square a. And in the denominator, we should write this equal to over here. Denominator is sin square a LCM, then sin a whole square, which will be sin square a. And this is a minus b. We can also write b minus a, so not make any difference. Cos a minus sin a whole square, and whole square of the numerator, whole square, right? Now we would make it upside down, and then the term cos a minus sin a whole square, cos a minus sin a whole square, this term, and cos a minus sin a whole square will get cancelled. So this would be equal to 1 by cos square a, 1 by cos square a divided by 1 by sin square a. So that division we can multiply and reciprocate the fraction cos square a by 1. 1? Yes, 1. So this is equal to cos square a by sin square a. Cos square a. Oh, is that so? No, it will go up. Hold on. This will go up. So this denominator is this thing is going into numerator, no? So well, this would be sin square a over 1. So which is equal to sin square a divided by cos square a, and sin square a by cos square a is equal to tan square a. So we also proved that this expression is also equal to tan square a. So we can say therefore, once we approve this, we can say therefore this expression we will write again, therefore this. Okay.